All right. Hello, everyone. I'm Bernd, and today is day 7 of Advent of Code. Today's problem was about file systems, and it was the first problem that needed some more involved code, in my opinion. So it's quite interesting. So what do we have? Our input consists of this kind of lines that is like us navigating the file system. So it has commands like change directory, and it lists the content of a directory. And we use that to explore the file system, and also we should use that to save the file system, and then we want to care about the sizes of directories. Particularly for part 1, we care about directories of total size at most this size, and we want to sum their sizes in order to get the answer. So how can we do that? So obviously we need to read the input and split into lines, and then a lot of code functionality is in this directory class. So what we have here, we initialize it with a name and potentially a parent if it has one. And then it also keeps track of all the files in the directory and all the subdirectories. And we also have a calculated size. And then it has a few methods. So for example, it has add file, which just adds a file. And importantly, files is a dictionary there. So it has the file name and then points to the file. Add subdirectory works similarly. And again, we have a dictionary, which takes the name, maps from the name to the actual directory, which will make some stuff slightly easier. Then the class also has the method calculate size. So in order to calculate the size, we set the size to 0, and then we go through all the size and add the file size to the total size. And then we also go through all the subdirectories and add the subdirectory size to the total size. So therefore we need a kind of get size function, how to get the size for a directory. So we check if we've never calculated the size, we need to calculate the size of that directory itself. Otherwise, we can just return the self-calculated size. This will help us to only calculate the size for each directory once. We don't need to go through it multiple times. Okay, then we have a simple class file, which just saves the name and the size. And then we need to create such a file system from the lines we give them as an input. That is done by first creating a root, that's a directory. We set the current directory to root. For simplest for making our lives easier later on. We also keep a list of all the directories. And then we go through all the lines in our input. And like, depending what the line is, we do something differently. So if the lines is given by this, that just means we change the current directory to the root. If the line is given by something like this, that means we want to move one level up. So we change the current directory to the parent of the current directory. Otherwise, if the line starts with this, we want to go into the subdirectory. So the subdirectory name will be given by the line, but we get rid of this first part. If we can assert that the subdirectory name actually does exist, or we know about it so far. And then set the current directory to the subdirectory, and here helping a dictionary helps us because we can just index the subdirectory dictionary with the subdir name. Otherwise, if the line is given by this, we don't need to do anything because we know like every line that's not in this function will be an output of this function. So we just know that this will be output of this list directory command. So these two options are outputs. So either our output line is like this, giving us a directory. In this case, we get the directory name by getting rid of this first part. And if it does not exist yet, we create a new one with the corresponding name, and the parent is the current directory. And we add it as a subdirectory to the current directory, and we also update these all directories. Otherwise, or if the line starts with the digit, something like this, we know like this, we have the file name and the file size, and we just create a file with that name and with that size and add it to the current directory. Okay, so that's it, I guess, now we can read the input and create a file system. So that this allows us to now fairly easily solve the problem. So we create the file system for the lines, and then our solution is 0, and then we go through all directories. And if the directory size is smaller than this value, we add it to the solution, just as we told we have to do. And nicely, so if we call this get size, only the first time we will actually calculate something. From the second time on, all the directories will already have the size stored, so we don't need to do any more work, so it's just to look at them. And yeah, that's it for part 1. We have our little test input given, and we know the goal result. So we can run this and it looks good. So therefore we can also run it on the proper input and it does give us the right solution. For part 2 it's a bit differently, so we look for a folder to delete so that we can install an update. So we have that much total space and we need that much space for update. So we know the available space for all the files we have is the difference. And then in order to solve it, we can just create file system from part 1. And then we again get like the root and the list of directories. And then the space we need to free is the current size minus the available size. So if we free at least that much, we know we can install the update. And we want to install delete as little as possible. So we keep track of the best so far. And then we go through all directories. If the size is smaller than what we need, we continue. It's not good enough to delete this one. If otherwise, we get the size. And if the directory we're looking at is smaller than the best so far, we update best so far. And it's better to delete that directory than the other one. And then the solution will just be best so far. So the smallest directory bigger than needed to free. And yeah, we can also run the test. And with a bit of luck, yes, looks good. So yeah, and we can also run it on the input to give us the correct result for the day. So yeah, that's it for today. I hope you enjoyed today's puzzle. Best of luck for the future and see you around.